So let's now begin to look at how this fits into the things that we have been talking about. Now, remember that I always want to make sure you are aware of what a particular topic fits into the overall goal. All right. So in this case, we haven't talking about um, descriptive statistics, and specifically, we've been focusing on summarizing, summarizing data. All right. And we have been able to see that we can summarize data by focusing on the center of the data, and also looking at how spread out the data is. All right. The data values are from each other. Now, when we're looking at the center of the data, we also focus on specifically what we call the measures of central tendency, measures of central tendency, and then we indicated that we're talking about the mean, the median, and then the mode. Then we started looking at how do you get a single value that um, tells you about how spread out the data values are. And here we started looking at measures of variability, or measures of spread, or measures of dispersion, 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 and then another name could be measures of variation, right? We said all these are names that refers to the same thing. Okay, then we indicated that the most common ones are the range, one, the range, two, the variance. We said the variance help us to find the standard deviation, right? The last time in class, we learned about different ways the standard deviation is applied, uh, comparison, comparison, um, in the empirical rule. We learned about the 68, 95, and the 99.7% rule. And we said the empirical rule is only for what? Bell-shaped bell-shaped distribution. We learned about the Chebyshev theorem, um, theorem, right? And we learned about that. The percentage is 1 minus 1 over k squared, and usually you're gonna times it by 100. We said that Chebyshev is for any distribution. We did a couple of problems that relates to that, and then we said there was another aspect, which is the z-score. The z-score, that's where we actually end the z-score. All right. Now, the portion of the measures of dispersion, or the measures of spread, that we didn't talk about is the fourth portion of it, which is number four. The most common is the interquartile range. All right, so that's what we will be focusing on today, the interquartile range. And then, as part of this lecture, we're going to use the interquartile range to also create what we call box plots. So I just want to give you an overview of where we are with this. Okay. All right. So in order to find the interquartile range, we have to find what we call Q1, Q2, Q3, first, second, and third quartile. I'll show you how to do that. We will learn how to do box and whisker plot. We've done this already, so that's not a big deal here. So imagine yourself spreading a given set of data in such a way that you line them up from the minimum to the maximum. Now, if you find out what is the exact data value in the middle, we used to call this the median, right? So when we do the median, basically what we're saying is that 50% of the data, it's below the median. Okay, help me with my below here. Um, so 50% of the data it's below median, and then we also could say that 50% of the data, 50% is above the median. So usually what we call this portion is that we call this the lower half, the lower half. And then we call this side the upper half. This side is called the upper half. This is the upper half. So the median separate the data into two equal parts so that you have 50% of your data value is below the median value and then 50% of your data value above the median value. Now, when we decide that we want to split the lower half into two, all right, now if you do that, then you're going to have 50%, 25% of your data here, and then you're going to have 25% of your data here. So this is a median, this is a median of the lower half, lower half. And we can also decide that we want to split the upper half into two. Now, if we do that, then we're going to have 25% of your data on the upper here, and then 25% of your data here. And this is the median of the upper half. Now, by doing this, we've been able to split our data into 4 equal parts, right? We've been able to split our data into 4 equal parts. Maybe 1 here, 2 here, 3 here, 4 here, and each part has 25% of your data, right? So when we talk about the idea of quartiles, quartiles divides your data into 4 equal parts, all right? And each one is a quarter, like 25 cents, right? Each one is a quarter. Each part that we see here is just like a quarter, right? That's 25, 25, 25, 25. Okay, now we have a special name that we call the median of the lower half. This is called Q1. Q1 is called the first quartile. It's also called the lower quartile. And it is a value that you have 25% of your data below that value, and then 75% of your data above that value. All right, so you could see if this is Q1, 25% is below, and then everything above is 75% of your data. Now Q2, it's the median itself, and we call that the second quartile. Second quartile. So Q2, what we used to call the median, right? It's also the second quartile, and it's so the median can also be referred to as the second quartile. Now, note that the median is such a way that 50% of your data is below it, and then 50% of the data above it, right? So let me make a long line here and say that 50% data below Q2, 50% of data above Q2. Then the median of the upper half has a special name called Q3, and we have a name, we call that the third quartile. All right, and it is also referred to as the upper quartile. And you have 75 of your data below Q3, and then you have 25% of your data above Q3. Sometimes you call it the top 25%, the top 25%. Sometimes we call Q1 the bottom 25%. Now, another name, like usually when you look at the percentage of data below a particular value, that also have a special name that we call percentile. So Q1 is the same as the 25th percentile. Q2 is the same as the 50th. So Q2 is the same as the 50th percentile. And then Q3, so Q3 is the same as the 75th percentile. All right, so percentile just means the percentage of data below or at a particular data value. All right, so take note of these different names that we have, the different names that we have. Okay, in other words, percentile divides the data into 100 parts, and 25th percentile means as a 25 parts below. All right, so quartile tells you the data point at or below. So the first quartile is 25% of your data below, second quartile is 50% of your data below, third quartile is the 75% of your data below. Okay, so I've indicated most of the things in here already. Now that brings us to the question of the interquartile range. Usually we use IQR to indicate the interquartile range. The interquartile range is, so that is a measure, it's a measure of variability or a measure of spread, right? It's also one of the candidate that gives you how we can measure or calculate the spread of a data. Well, we use the interquartile range when data is skewed or when data has outliers. All right, so when the data is skewed or when the data has outliers, the interquartile range is a preferred measure of it's a preferred measure of variability. Okay, now the question is, how do you first, what is the interquartile range? The interquartile range is a range of the middle 50% of your data. Now remember when we started, I did something like this, say this is the minimum, this is the maximum. This happens to be Q2, which is a median, this is Q1, and then this is Q3, right? So when we say the range, and we indicated that each one of these, this is 25%, 25%, 25%, 25%, right? Because we break it into 4 equal parts, 4 quarters, right? When you change a dollar into quarters, you get only 4. So the interquartile range is a range of the middle 50% over here, the range of the middle 50%. So from Q1 to Q3 is the range of the middle 50% of your data, and that is what we call the interquartile range. All right, so this area, it's your interquartile range. So interquartile range therefore is Q3 minus Q1, right? The beginning and then the end. All right, Q3 minus Q1. So what we're gonna now do is, how do you actually calculate the interquartile range from a given data? All right, so if you're ready, let's see. Well, so we know for us to find the quartile range, we need to first find the quartiles, right? So let's say they give us data. Now I'm going to do 2 examples. One is when n is odd, and then I'll do a second example when n is even. So let's take the first example when n is odd. So n is equal to odd. In this case, n is 15. When you start the problem, the first thing will be arrange data in order, right? Preferably put it in increasing order. Okay, now the second thing we will do, um, you're gonna find the median first, right? Median is the same as Q2, so you find Q2 first. To do that, you could find the median position. Remember the formula for median position, n plus 1 over 2. So you're going to do 15 plus 1 over 2. That will be 16 over 2. That will be 8. So the value of the value in the eighth position, the eighth value, the value in the eighth position of your data, of your arranged data, becomes the median. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So this is the median. So here the median will be what? 43. So Q1, Q2 is 43. Okay, so that is how we could find Q2, just like you've been doing before. Now next, what you would do next will be to find the come back to the data, right? Because we have odd number of values, it's going to be very difficult to split this into two equal parts. All right, because the only way you could split it into two equal parts is if you have 14 data, so that there'll be 7 in the first half, and then 7 in the second half, which means that we got to drop one number, because if you want two equal parts on the lower and on the upper, then we got to drop that number. So in an odd, when you have odd number of values, you're going to exclude the median, exclude Q2 from your data, so that you have equal number of data points on the left and an equal number of data points on the right. So these should be excluded. If you exclude this, then you're going to get what? 7 data points here and then 7 data points over there. All right, so next thing we're going to find, so let's first find Q1 and Q3. So Q1, now Q1 will be, so there's 7, so 7 plus 1 is 8 over 2 over 2, so that's the fourth. So 1, 2, 3, 4. So this is the fourth value. The fourth value is 37. So Q1 is 37, and then Q3 we can also count for 1, 2, 3, 4 here. So Q3 is 48. Q3 is 48. Therefore, your interquartile range will be Q3 minus Q1, which is 48 minus 37, and that gives you 11. And we could say that the range of the middle, 50% of your data, right, set. So that range vary by at most 11. That range vary by at most 11. Okay, so that is how we could find the interquartile range. Now, before I move on, I just want to also mention here that in statistics we have something that we call the five number summary. Sometimes the question may say, they may just give you a data just like this, and then the question will say, give us the 5 number summary. The 5 number summary, number one, is the minimum. What is the minimum of this data? The minimum is 28. The next is Q1. So number 2 is Q1. What is Q1? Q1 in this particular case happened to be 37. Then the next is Q2. 2. What is Q2? That is a median. We found a median to be 43. Then the next is so number 4 is Q3. What is Q3? Q3 happens to be 48. And then number 5 is the maximum. What is the maximum of this data? The maximum of this data is 55. So if a question asks you to find the 5 number summary from any given data set, all right, then take note that they're asking you for the minimum, they're asking for Q1, Q2, Q3, and then the maximum. So please take note of that. Now, why don't we take a data where n is even? So n is equal to even. All right, so in this case, n is 20. So let's see what we could do. Now, because n is even, in this case, n is 20, you can have 10 for the lower half, and then you could have 10 for the upper half. So that's good. All right. So in this case, just looking ahead, you may not need to drop anything because you have equal number of things in the lower half. You have equal number of things in the upper half. So first, we're going to start by you arrange the data. That's very important. Okay. So they gave us a raw data. Raw data is a data that has not been arranged at all, and then we arrange it. You arrange it. So this is the arranged data. Okay, so what we could do is that first, after you arrange the data, the next thing will be to find the Q2, which is the same as the median. All right, to find the median, remember that the median position, n plus 1 over 2, that is 20 plus 1 over 2, that will give us what? 21 over 2, which is what? 11 point, is it 11.5? No, 10.5. So it means that you're looking for the 10th value and then the 11th value. So the median is between the 10th value and then the 11th value. Okay, let's see. What is the 10th value? What's the 11th value? So when we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is here. So the 10th value and the 11th value are here. Okay, so we're gonna do, so the median will be 20 plus 25 divided by 2. That gives us 22.5. So that's median. I should write Q2 here. Made a mistake. Then the third thing we're gonna do, number 3, we're gonna find Q1 and Q3. We now know that in this particular case, because you have 10 data points here, right? So that will be the 5th and the 6th, and this happens to be the 5th and the 6th. So Q1 becomes 15 plus 15 over 2. That gives you 15. 30 over 2 gives you 15. Now Q3 will be the same. The median of the, so this side is the lower half. Remember that this is the lower half, and then the other side is the upper half, right? This side is the upper half. Okay, so when you're looking at the upper half, Q3 is now going to be 40 plus 45 over 2. That gives you 85 over 2, and that will be 42.5. Now, so we have the data points that we need to find the interquartile range. We have a Q3, we have a Q3, and then we have a Q1, Q3. Okay, so we can confidently say that our interquartile range, which is Q3 minus Q1, would give us 42.5 minus 15. That gives us what? 27.5. Now take note here that you have all your 5 number summary, right? Your five number your 5 number summary, your minimum, which happens to be 5, your Q1, which happens to be 15, your Q2, which happens to be 22.5, your Q3, which happens to be 42.5, and then your maximum in this case, which happens to be 85. All right, the maximum is here, maximum, and then the minimum is here. This is minimum. Okay, now we can use the interquartile range to find outliers. All right, we can use the interquartile range to identify outliers. So we have something called the 1.5 times interquartile range rule. Okay, so first let's note that um, we can use the IQR to identify outliers within the data. Outliers are data points that are far away from the rest of the group. Okay, but what is the correct measure that we can do? In order to find outliers, we have what we call the lower end outliers, and then we have the upper end outliers. Okay, now take note here that, for example, if I have um, let me see where let me draw it here. If I have my number, the fin here, we know this is the minimum, this is the maximum, this is Q2, this is Q3, this is Q1, right? If there are outliers, they are more likely to be on the extreme end of things, somewhere here, somewhere here. So here, outliers are more likely. So outliers are more likely to be somewhere here or somewhere here, right? Outliers more likely. Okay, so knowing where, so when we talk about lower outliers, then we are talking about somewhere here. When we talk about upper outliers, we are talking about somewhere here. All right, so the lower outliers, anything below the formula Q1 minus 1.5, always 1.5 times the interquartile range, and this side is anything above Q3 plus 1.5 times the interquartile range. All right, so that is the formula. In your homework tonight from this section, you have a lot of questions that deals with you identifying the outliers using this formula. Okay, so um, an outlier, it's any value, so we could have lower outliers, upper outliers, and then we have this formula. So why don't we take our example so we could do it? So you've been given a data set, you've been given a raw data, and then they want you to identify outliers. So first you have to arrange the data. All right, you have to arrange the data. Now we've worked with this data already. We know that Q1 happened to be what? Actually, let me write a 5 number summary because that will make our life much easier. All right, so we know that the minimum is 5. Q1 is 15. Q2 is 22.5. Q3 is 42.5, then the maximum happened to be 85. Okay, so when so these are the number 5 number summary. All right. We also know that the interquartile range is Q3 minus Q1, and we work it out. We were able to get 27.5. So we know the interquartile range. So in terms of outliers, we need to first find the lower end outliers, and we know the formula is anything below any number in your data below Q1 minus 1.5 times the interquartile range, right? 1.5 multiplied by interquartile range. Now our Q1 happened to be 15, minus 1.5 times 27.5, and this gives us what, 15 minus 41.25, and that gives us negative 26.25. All right. If you cannot see it, it's worked out over here for us. So you're gonna ask yourself, is there any number below? Is there any number below this value? Right. So we have no lower end outlier. Now let's now look at the upper end outlier. So upper end outliers. So anything above Q3 plus 1.5 times the interquartile range. Okay, so here, what you will notice is that Q3 is 42.5 plus 1.5 times 27.5. That gives you 42.5 plus 41.25. That gives you 83.75. So is there any upper outlier? Our answer will be yes. Here, our answer is no. But here our answer is yes, because we see that 85 is above, so the outlier is 85, right? 85 is above. 85 is above this number. So that is an outlier. So this is an outlier. An outlier is a number that is far away from the rest of the group. All right, so we have 85 is an outlier. So that's how to find outliers.
Hey, can I ask a
Okay,
question real quick?
yes, go ahead, please.
So, what about the first one? You got negative 26 as the answer?
Okay, so you're gonna come back to the data, right? Like when we get the negative 26, we are asking ourselves, is there any number below negative 26, right? But when you look at the data, there's no, we don't even have any negative number.
Right.
So that's why we said there is no lower outlier.
Okay.
But here there is a yes, we do have an upper end outlier. We did not have lower end outlier, but we did have an upper end outlier.
All right. That makes a lot of sense. Thank you.
Very good. And usually when they ask for outliers like a data like this, they asking for both the lower end and then the upper end outliers together. Okay, so now the five number summary can also be used to display on a graph that we call the box and whisker plot. All right, the whiskers are like the cat whiskers. Okay, usually we have two whiskers. We have a lower whisker and then we have an upper whisker. All right, and usually, so a box plot, by definition, a box plot is a graphical version of the five number summary. All right, so you have all the five number summary: the minimum, Q1, the median, Q3, and then the maximum. Okay, um, we know the middle here. So this is Q1 to Q3. So this is actually the interquartile range, right? Or the middle 50% of your data. Okay. Now for this class though, when we are drawing an outlier, we're going to be doing what we call the modified outliers. Do I have it somewhere here? We're going to do what we call the modified outlier. Now, the modified outliers include any suspected, the modified box plot. A modified box plot include any suspected outliers, right? A regular box plot do not include outliers. Like this is an example of a regular box plot, right? Like I suspect this is like an outlier, but a regular box plot do not include that. A modified box plot do include outliers. Okay, so why don't we use this example, the example that we had before, to show you how we can create a regular box plot, a modified box plot. So if even I ask you to do a box plot, I'm asking you for a modified box plot so that you could show your outliers. So let's see how I can show you that before we leave. Okay, so we have our 5 number summary already here. These are given. Okay, we have it here. So the first thing, draw a number line. We're ranging from 5 to 85. So we could do 0, 10, 20, 25, 30, 35, 40. Oh, I didn't draw it that long. 45, 50, 55. Okay, so forgive me here. Why don't I just use what I have on the screen here just to save us some time? So so you start with the number line. So let's suppose that this is a number line that we came out with. Okay, so you start with a number that is below your minimum, and a number that is above your maximum. The first line you're going to draw, so you're going to draw a line. So first, draw a line for Q1. So you come to Q1 and draw a line, like the line that I'm making here. Draw a line for Q1. All right, so make a line for Q1, a line here like this. And then you could write Q1 on top. Second, make a line for Q3. So make a line for Q3. Um, make a line for Q3. Right, Q3 is what, 42 point, this is 40, this is like 45, so that's somewhere here. All right, so make a line for Q3. So make a line for Q1, make a line for Q3, so this is Q3. Then make a box out of the lines. Right, make a box out of the lines. Oh, my box doesn't look like it. All right, so make a box out of the line. So you have this, you have the line here, you have this, make a box out of the line. A nice box. All right, down. So first you make a line for Q1. 2, you make a line for Q3. Then 3, you make a box out of those things. 4, you make a line for Q2. All right, so here Q2, Q2 is 22 point something, so make a line for Q2. Then, because there's no lower outlier, you make just a line to, this is 5, right? The minimum is 5 because there's no lower outlier. But there's an upper outlier. So what you usually would do would be to circle the outliers in your data and then ask yourself, what is the last value before the outliers? The last value is 65. So you're going to draw the upper whisker in this case up to 65. So up to 65. This is 65. All right, then you're going to make asterisks for the outliers. So if there are outliers in your data, you're going to make asterisks for them. Okay, so if there are 2 outliers, you're going to make 2 asterisks. If there's only, like here they have only 1 outlier, so you make them. So note that this line ends at the last value before the outliers begin. If there was a last value here before the outliers, we would have done the same thing. Okay, so this is called a modified box plot. The modified box plot is a box plot with outliers on it. Now, finally, I just have 1 minute, but let me say this. After you've drawn the box plot, you'll be asked to judge whether it is symmetrical. Now, to judge that, look at the spread in the box. All right, if the spread in the middle, if the spread is the same, then it is symmetrical. If there is more spread, so here, more spread on the right, then it is positively skewed. If there is more spread on the left, then it is what? Negatively skewed. Now, how do I know? Because if you punch 25% of the data here and 25% of the data here, this is more spread out. All right, so I think I have like the similar one here. So there's more spread here, so this is skewed to the left. there is more spread here, this is skewed to the right, and there's equal here, so this is symmetrical. Okay, so I will end the lecture today, and I would see you on Wednesday.